Okay, Scantech Hangzhou Company Limited. It's a company based in China, specifically in the city of Hangzhou in the southeast of China. It's about a 3 hour drive by car from Shanghai, or about an hour if you use the high speed rail. Um, Scantech is a company that specializes in developing, manufacturing, and of course, selling 3D scanning technologies. Okay, and these technologies vary in range from structural light scanners used in um, hobbyist and other, medical applications, since it uses structural light or white light scanning, and then moving all the way up to more metrology intended applications. So we offer different scanners with different levels of accuracy and resolution, and also applications, including optical trackers as well. The company employs about 200 people in total. That is a combination of the people that works at our main offices in China, and also our recently opened office to Global Chief Commercial Officer. That basically responsible for the global sales strategy of the company and deployment of our expansion plans to overtake international markets. The company has been selling internationally for quite a long time right now. My estimate is that since I know them, it's about 5 to 6 years in that range. And we have just recently expanded our to our first international overseas branch office in Germany. The plan is to continue our expansion, and of course, I mean that will depend on the success that we can attain doing or putting in place our expansion strategy. So, as the global chief commercial officer, I'm responsible of designing and implementing the sales strategy, and basically designing and implementing the business model that we use, creating the guidelines, and provided all the necessary recommendations to prepare our team to be better prepared to attend the needs of our international customer base. Just like I mentioned very briefly in my introduction, is that 3D scanning is nowadays present in many different fields and applications, ranging from people taking their first step into 3D scanning to medical applications, hobbies, animation, etc., etc. But the technology has been around for about 30 years. And in particular, I've been involved in this business for 25 years in total. So the range of applications is very broad, and it's just getting wider and wider every day. And that is because in the last 10 years, it has received a major endorsement from companies perceived as traditional companies in the metrology business. I'm putting emphasis in metrology because there is where our focus is in the industry and market that we work on. And so recently acquisitions made by some of these traditional companies like Size, acquiring GOM, and other companies in this environment, and other companies making similar moves, is creating a more trustworthy environment for 3D scanning to be accepted as a mainstream tool for accuracy and resolution needed in inspection applications. Okay, so of course, 3D scanning offers the advantage of having a very high speed data acquisition rate, and also doing so with very high accuracy and resolutions um, in performances. That is very important in any engineering aspect of the work that is done typically in quality control, design, reverse engineering, et cetera, et cetera. So 3D scanning offers similar accuracy that were always only reserved to traditional CMM machines in this case. It has become very, very close to the most demanding accuracy requirements used in metrology applications. So, of course, even the high speed of data acquisition, the reliability and quality of the data that you can obtain using 3D scanning technologies, now you can use this to cut time needed to do inspection or to create a reverse engineering, and then of course generate a CAD model based on the reverse engineering scan data. So the cost reduction is very, very important in the industrial environment. It's perhaps one of the most important variables in reducing manufacturing costs overall. So I would say that that is the number one advantage that 3D scanning systems offer. That's one, but not the only one. The other one is that because of the advances made in the accuracy and resolution offered by 3D scanning technologies, this data is also of high quality in terms of the accuracy. I'm sorry for being redundant on that one. So that gives you very reliable data to base your decision on in terms of quality control and inspection in general. Something that with different terms has been, being used in 3D scanning for a very long time. So this is nothing new. I mean, one of the main purposes of 3D scanning, or one of the main applications, let me rephrase that, is that you were able to create a digital model of an existing part for which you didn't have legacy documentation, legacy parts that were too old, that you are still being used in your manufacturing process, but you long ago stop having the blueprints of that part. So of course, once you have a digital model of the part, it's easily to archive, to create a database of all those parts that you are normally working with, and manage them and use them as you need them, modify it when you need them, etc., or update as needed. Because of course, many products, use common or legacy parts, but there are, experiencing later some light modifications, some more radical modifications, but we always start with a base model, okay? And that base model is what is known right as the digital twin. So this is something that is not new. It's new for the additive manufacturing industry, which is kind of lacking in taking advantage of 3D scanning. For me, in my experience, since I have experience also in additive manufacturing, it's very surprising and appalling to see the disconnect existing between additive manufacturing and the 3D scanning world. Because especially what do you print on a printer? It could be of any kind of printer. It could be a resin printer, metal printer. You're using CAD models, and people don't normally stop to think, okay, where are these models coming from? And I would tell you that more than 50% of those models are not coming from CATIA or any other CAD solution like SolidWorks and many others. So that's one, the obtaining of the CAD models to be used in additive manufacturing, and then of course the quality control process after you have printed or manufactured your part. So if you integrate all this process, of course you are going to take you can take full advantage of having a digital twin, okay? Having parts that you don't have to physically inventory, but you can have them in a digital format inside of your computer, your servers, and use them on demand. Well, actually, they go hand in hand. So it's impossible that 3D scanning will overtake internet, but actually 3D scanning will benefit of development and advances in internet technology. For example, data mining, the speed of file sharing, storage capacity, et cetera, et cetera. But answering your question, no, the answer is no. It will not outpace the development of internet, but will take full advantage of all the advances made in internet. Okay, just like I mentioned in my previous answer, it's a lot easier and more financially convenient for a company, instead of storing physical parts, having to pay for extra storage, extra storing shelves, et cetera, having people to run inventories, to have everything in a digital format, okay? So of course you will not be able to completely stop using a physical inventory, but for those parts that you are using more commonly, or the ones that you can foresee reusing or redesigning for applications in new product development, of course you can greatly benefit from using, the digital twin or the digital inventory of parts that you have, okay? Another application that I forgot to mention that I can now share here is that digital twins or digital inventory of parts also allows you to improve the design and the features and performance of parts you have been using, especially if you integrate those with design and optimization or simulation software. So you can have parts, that are stored as a digital twin that your engineering department can continue working in development and improving them using this type of technologies, using, design optimization, simulation, et cetera, et cetera. That will allow you to continue improving existing parts or repurposing them for use in different applications. So that is one of the advantages of having a digital inventory of parts that you're commonly using, or just simply to have a legacy inventory of digital twin parts. I think is a great platform that hopefully is going to help us to break that gap that I was mentioned that exists between additive manufacturing and 3D scanning technologies, because both of them can go hand in hand. Actually, they one is here to serve the other. In this case, 3D scanning. It's going to enable engineers, to design and build better parts. Design it well because you can easily create a mock-up using any type of material, even cardboards, scan them very quickly, and then do all the modifications or changes that you want to do in the digital model. Then if you integrate that with the solutions that I just mentioned, like digital optimization and simulation, then you can make sure that you're going to be saving a lot of cost when you 3D print one of those parts. And then again, after the process is completed, you can use 3D scanning to verify that the quality of the product that you built is as built. So a platform like such as Teco News is a great platform to bring this information to the masses, to those out there interested in additive manufacturing or 3D printing, even for hobbyist purposes, to learn about 3D scanning and how 3D scanning can help them to improve and save money in their manufacturing enterprises.